Hello everyone. Today we are going to learn about recurring decimals, right? Recurring decimals are those decimals that is repeated again and again. For example, 0.6. In this question, right, the dot is on above 6 here, right? Or you can write down 0.6 dash a bar on it, right? So it means that 0.6666 and keep repeating and so on, right? So this is called recurring. So how did I get this 0.66666? The fraction is 2 over 3. If I will divide this 2 over 3, 3 will be outside and 2 inside. We need to make this too big by putting this dot on the top, and then I'll take 0. 3 6 are 18. 20 minus 18 gives us 2, and then we take 1 0 here. Then again 3 6 are 18. Then 2. So it is recurring. It's keep coming like 6 6 6 6 6 and so on, right? So the fraction form is 2 over 3 and the decimal is 0.6666, and though it's a recurring, so that I need to put a dot above this 6. So this is the example of recurring. Now the question here is, if I'll give you that you need to convert this recurring into a decimal. This is the question. Convert recurring and decimals into a fraction. Okay. So the first example is 2.16, and the recurring digit here is 6, right? So how are you going to find out? So there are a few steps that you need to remember here. The first one is that you need to check that after this decimal, that after how many numbers this recurring digit start, right? So let me make a box here. So this 6 is my recurring number. Means that this number is going to be write down as a recurring is like 2.1666 and so on, right? This is how that you're going to write down this in the recurring form. So 6 is the recurring. So now here, are you going to find out the fraction form for this recurring? That you need to check here that when this recurring start. So first of all, you need to tell me that the starting point. The starting point after the decimal is one digit, right? After one digit, this 6 starts, and this 6 is a recurring number. So here I'm writing one digit, okay? After one digit. So it's after one digit means that you need to multiply by 10. right? Because the value for the 1 is 10th. Okay, so we're going to multiply with 10, right? This is the starting digit. Now the ending digit is like the recurring point the 6 starts from here, right? It starts from here, and before this red line I have only one digit, so that's why I need to multiply by 10. This that you need to remember here. Okay, now the recurring number end, this is the ending point, right? This is the ending point. So recurring number end from decimal till the end, like there are two digits, right? So here the ending point, I'm writing here, its ending point is like after two digits. So I'm going to multiply by 100. Okay. Okay. Now, what we need to do here, that assume that this 2.1666 is your x here. Okay. So I am writing x equals to 2.1666 and so on. Right? So I'm giving that this number 2.166 as an equation. So I'm making this equation. I made this equation here, right? X is equal to 2.166. Now what we need to do here, that first of all, we need to write down the ending point. We need to multiply this 2.1666 with my ending point. And ending point here, it's 100. Okay, so here I'm multiplying the first part always with the ending point. So I'm multiplying this whole equation, like my left hand side and right hand side, both the sides with 100. Okay, so when I'm going to multiply x with 100, it gives me 100x equals to, when I multiply this number 2.166 with 100, so this point shift two digits ahead, right? So it will become 216.66 and so on, right? Now, what I'm going to multiply after ending point, the starting point. The starting point was 10, right? So I'm multiplying the starting point with 10. So when I multiply this equation x equals to 2.1666 with 10, so it gives me like 10x equals to, when I multiply with 10, so the point shifts forward one digit ahead. So it will become 21 point will come here, right, after 1. So 21 point, and after that 6. Okay, after this 6. Okay, now what we need to do, and after this, that we need to subtract. We need to subtract here. Means subtract these two terms. Subtract. So when I'm subtract these two equations, so 100x minus 10x gives me 90x, right? Equals to here, and this is the point. The thing is where the alignment of the number is very important here, right? And your right hand side always be with the same digits, like 666, and the answer for the right hand side always be 0. So point will come here, and then the 666, when we minus it, it gives you 0. Okay, and when we minus the left hand side, gives you 6 minus 1 gives you 5, and then 1 minus 2 is not possible. Let's borrow. 11 minus 2 gives me 9. Okay, and 1 will come as it is. So 195.00. Now, what I'm going to do here, that x equals to 195 divided by 90. The reason 90 and x, they both are multiplying with each other. So when we shift towards the right hand side, it will be divide with this 195. Okay, now let's simplify. Okay, we simplify with the digit 5 because last digits are 5 and 0. So 5 times 1, 5, and the remainder is 4 here. So it is 5 8s are 40, right? 5 ones are 5, remainder 4. So it becomes 40, 5 8s are 40. Now 5 3s are 15. I'm taking these two digits, and 15, 19 minus 15 gives me 4. 45, and 5 9s are 45 here. Okay, now I'm writing x equals to, here we left with 40, 18 left here. Okay, 39, 39 over 18. Now we still divide by 3 times table. So 3 6 are 18, and 3 thirds are 3, and 3 13s are 39. Okay, so here we left with x equals to 13 over 6. When I'm going to divide this with the calculator, so okay, press 13, okay, and then divide it by 6. So it gives you answer 2.16666. This answer will come again. That was the question, 2.16666. Okay, so this is how that we are finding the recurring, we are converting actually recurring into a fractions. Okay, I hope that you people understood this concept. Subscribe my channel. Thank you.